All right, looks like we're finally live. Hello everyone and welcome to another Zozin session. How about that? How about that? I bet you didn't expect that shit to happen. Welcome everyone. Today is basically the fourth day of Advent of Code in God's Temple. So today we're gonna just do the fourth day as usual. Before we do though, I think we need to make a little bit of an announcement on our Discord server. Red Circle live on Twitch, and I just realized that I didn't bring the dashboard, so I should have actually brought it super quick, but I mean, it's not that big of a deal. So today is the day 4th, and I'm gonna give the link to the Twitch channel, twitch.tv/Debugging, and I'm gonna ping everyone who's interested in being pinged. There we go, the stream has officially started. The stream has officially started. Hello everyone, welcome, welcome, welcome. Hello Membrilla Amarillo, hello Lenny Lowe. Welcome. So, before I start, I wanted to actually do a little bit of a refactoring of our solutions, because we have a little bit of a common code that I keep reusing across several solutions, and I thought that I'm gonna take that code and pull it out into some sort of like a utility module so I can reuse it in other solutions. So that's basically what I wanted to do today. Oh, thank you for reminding me to change the title. Yeah, that's right. So the problem here is that opening Twitch when I'm streaming is extremely slow. And I forgot to bring in the dashboard. So like, look how much time it takes to actually like start it up. Right. And now I clicked on this thing and I need to wait until it shows, and then I need to do pop-up, and then I have to close it yet again. It's just like, it's so slow. It is so slow. Oh, it feels like CIA infiltrated Twitch. That's what it feels like. So let me quickly change the title to day 4. Thank you so much, everyone who reminded me about that. Okay, so let's go. Studying HolyC 2021. You can find the source code to my solutions in the description right here. So all of the necessary links are available in the description. And if you're watching live, I'm going to copy paste the solution in the chat. Okay, so let's go and start the HolyC image. So I also need to provide the password, and there we go. Hello, everyone. Loading the compiler. Okay, go. I need to answer no, then I'm gonna close the auto completion, and I like to sort of like expand this entire thing. Maybe I need to put all of these actions into my home script, because you can actually customize how the operating system starts up. So maybe I'm gonna get rid of the tip of the day. No, I'm not gonna get rid of the tip of the day. I think it's a pretty useful feature. I probably want to get rid of the take Tor, but I'm not sure. So this thing includes once, so that means it includes it from the C or something, but I don't want to go into that on the stream. So I'm going to go into that a little bit later. So let's go to the HolyC folder, and let's take a look at the first solution, right? So as I already said, there is something that is shared across several solutions, and this is something that we need to pull out. So the first code that is quite often appears, right, is this one. Essentially, I have some stream of bytes, right, basically the bytes that I read from a file, and I chop off the numbers from them. I parse the numbers out of that stream of bytes. So what I was thinking, it's actually a good opportunity to use my string view library, right, so let me actually show you what I mean. So I have a pretty cool string view library, which basically defines my own string, which is the amount of characters and the pointer to the beginning of the string, and then it defines a lot of useful operations on that string view thingy. So, and while I was solving problems in HolyC for Advent of Code, I was constantly thinking it would be kind of nice to have this sort of library, but for HolyC. So I think what I'm going to do, I'm going to just basically like partially re-implement that library, but in HolyC, and put it into some sort of like a common module so I can reuse it across several solutions, right? So that's what I wanted to do before I start the 4th day. So, and I'm going to put this thing in the description for anyone who's interested in what I'm talking about. String view library in C. So this one is my string library in C, and I'm going to copy paste this thing in chat. Porting is Philippe to TempleOS. Yeah, pretty much, almost. It's not going to be like one-to-one port, and I'm not going to port everything. I'm just going to port like a bare minimum that I use in my solutions, right? It's going to be like, I don't know, maybe a couple of functions and the structure definition or something like that. So we're gonna actually start doing that in this solution, so I don't have to jump between the files or anything like that. The first thing I want to do, I want to define the string view structure. Unfortunately, there is no structures in HolyC, right? If you try to do something like struct string view, first of all, struct is not even highlighted. Second of all, let's actually go ahead and define everything. So this is going to be i64 count, all right, and this one is going to be u8 data. And if I try to compile this entire thing, it is not going to compile. It will say undefined identifier at string view. So which is kind of weird. Like, it doesn't even complain at struct. It complains about string view. But here's the thing, so there's no structures in HolyC if I remember correctly, right? So maybe I should have to put like a semicolon. Yeah, it still complains. There are only classes, right? You can define classes. And weirdly enough, classes are just like pure C structures. They're not like C++ classes. They cannot have methods. So semantically, they're pretty much the same as the C classes, as the C structures, but they just called classes. I think it's not entirely true. I think there are some ways to sort of like do unions and some sort of like a type hierarchy, but it's not OP. Yeah, so it defines like a class for i64. As far as I know, i64 is not just a primitive type, it's a class. And I wonder if I can actually yeah, I think I can jump to the definition i64. Yeah, there we go. It's like, it's a union, right? And union is almost like a class, and the primitive type is i64i. But i64 is a union that allows you to access different parts of the i64 integer. So this is really interesting. Right, so this is a very interesting feature. You can define a class, and then you can say, okay, you can access this class as a primitive, and if all of the fields fit into that primitive, it's going to be that primitive, and then you will be able to access different parts of that primitive or something like that. So it's kind of really interesting and weird at the same time.
Enter my holy temple Sinpai Tsudingasem.
Thank you so much, Gia, for 30 months of tier 2 subscription. Thank you. And welcome to our Epic Temple Club. Cheers. Thank you. 30 months, oh my god. All right, so class is going to work, right? And one of the operations that we have in here is basically chopping the number. So what I want you to do, maybe I want you to define something like this. How am I going to say that? SV chop i64, right? And I'm going to accept string view SV. You know what? I don't really like to type a lot, especially in such a tight text editor, so I think I'm going to actually rename string view to SV. Right, so, and this is going to be SV, which will reduce the amount of things I have to type. And this entire thing is going to return i64, right, and then we'll have to define it like this. So, and essentially I'm going to just like move this repetitive code into this function, right? All right, how are we going to do all of that? str to i64, I have to provide the pointer to the beginning. The beginning starts here, sv data. Then I have to provide the radix. Okay, I think sv chop i64 has to has to have a customizable radix. So let's actually accept the radix here as well, because who knows, maybe I want to customize it. In fact, I can make it default. Yeah, what's cool about HolyC is that it finally has default parameters. It's semantically very close to C rather than C++, but it has some of the C++ nice features like default parameters and stuff like that. And you know what's cooler is that the default parameters don't have to be at the end of the function. That's what's cool about all of that shit. They don't have to be at the end of the function. So if you have something like u0 foo, you can have something like i64a69 and then i64b, and that is going to work. The question is, how would you specify b then? Well, you specify it like this. So you skip the default parameters. You literally skip them. So if you have several parameters in here, so i64c, which also doesn't have the default, you would specify it like this, 23, then you skipped one, and here's another one. So, which is actually kind of interesting. Yeah, so you literally just skip it, and that's fine. So that's a very interesting, like a fresh approach to the default parameters, I think. I'm not sure if it's legal, but I like it. You mean, where would it be illegal? In which states of the Russian Federation would that be illegal? Also, I actually wanna... Oh, goddammit. I pressed that thing yet again, so let me get rid of that. Hopefully, yeah, there we go. So, alright. And then here I have to provide the pointer to the end, right? So we'll have to allocate that end somewhere here. U8 and P, and then this entire thing should return the result. There we go. After that, I need to probably subtract the size of this entire thing. So I need to take end_p minus sv data. So this is basically the end pointer minus the beginning is how many characters we consumed, and this is the amount of characters that we want to subtract from the final size of the string view. Right, so that's basically what we want to do. And then I'm gonna assign the new beginning to the end. Right. And that's pretty much it, and the only thing I need to do here is just like return the result. I think. And if I try to compile the entire thing, everything compiles. Oh, here's another cool thing. You can always check how the compiler compiled, basically the generated assembly. So, oh yeah, thank you so much. So it's minus equals, of course. Of course it is minus equals. So ufsv chop i64, right? And then you're gonna run it, and there we go. So here's the generated assembly. So this is how that function looks like in assembly. And to be fair, it generates pretty small assembly, not gonna lie. So it's rather compact. It's definitely more compact than whatever Porth generates, right? So, but Porth is not finished yet. Terry worked on this thing for like more than 10 years. I worked on Porth like for how many, 3-4 months or something, and not even actively, not even every day. So all right, so, and essentially what this function does, uf, it just prints the assembly, right? We can even take a look at the definition. We can even go into the implementation of that function, right? And just read it and stuff like that. As you can see, here is the function. It finds the function in a hash table, so there's a fs. Oh shit! So, alright, so all of the compiled functions are located in some sort of like a global hash table that you can actually query, and you can query things by name, and then, yeah, that's actually pretty cool. And then it calls to like an actual disassembly or something like that. That's very interesting. You can even explore how things work on this entire operating system. It looks like shit. I'm sorry, Terry, but it like UI looks like shit. But conceptually, it's fucking amazing. Like, I wish there was something like TempleOS, but with actually usable like UI and UX, and it would be like holy fucking shit. So, yeah. It's just freaking amazing. Like, I really like how explorable it is. You just like, yeah. From time to time, I just like, you know, disconnect from the internet and I open up TempleOS and I just explore it. It's an operating system that is interesting to just explore. right? It's almost like you're playing like an adventure game, right? You never know what awaits you ahead, right? So you just dive into the code of the Temple OS and you just explore it, just use different functions, and you always explore something new about this operating system. It's just so fucking amazing. I really like it. Okay, so everything seems to be compiling, and let's see how we can use this function. So first of all, right, so here we have a begin and here we have a size. Though, interestingly enough, I always need to keep track of the begin, otherwise I won't be able to free it, right? Because every time you do file read, it actually mallocs it. So I guess I'm gonna just keep it then. So here I'll have to construct the new string view, right? So this is gonna be SV, right? And SV count is gonna be equal to the size that we just read, and SV data is gonna be equal to the begin, right? And while SV, maybe I should have called it count, actually size rather than count, because then it would be easier to, you know, customize the code, to modify the code. That's what I was trying to say. So let's actually call it size. So size data. Maybe I should also call this thing a begin of some sort. I'm really not sure. But I can try. Okay, so here's the begin, then size, and minus begin, and then begin is basically equals to end p. Okay, so this is the size, and again, the way I want you to approach that, I want you to just define this thing in here and then say, okay, SV begin is now equal file read SV size, and then it will just work. But then as I actually like parse everything, I will forget the beginning and I won't be able to, you know, to free that thing, which is kind of a shame, but I can do something like, I don't know, let's call it like saved begin. Right, SV begin. It's a saved begin, and then I free that saved begin. Saved begin. All right. So, and while the SV size is greater than 1, I should be able to do the following thing. I should be able to say x equal SV chop I64, pointer to the SV, and the radix. I don't have to provide the radix. So after that, this should be basically it. Right, so so this single line allows me to essentially remove this line and these two lines, right? So it just allows me to do that. Very straightforward. So we basically consume that thing over and over again. Looks a little bit better already, I think. It does look a little bit better. So let me go ahead and just maybe comment out the part 2, and it doesn't even compile, so because we have unused variable size. So let's go ahead and remove that unused variable size. So it's located in here, and if I, yeah, there we go. So everything's fine. Cool. The next thing I want to do, let's get rid of the unused variable size in here and do the same thing. SV, then SV begin, then SV size, and here I don't have to have this thing, but I do need U8 saved begin, and I just assign SV begin in there. SV begin. So, and here we have A, B, C, D. So, and for each character in here, for each variable, we have to actually do 3 lines, but now with this function, SV chop I64, you can just do SV and that's it. So it allows me to just remove this stuff. Okay, and it kind of like didn't work exactly as I expected, but that's fine. SV chop I64, SV, and now I'm gonna take this thing and put it like this, SV chop I64 SV. There we go. So that made this code a little bit easier to read and a little bit easier to maintain. Did it not? I think it did. Right. Yeah, so you just basically chop I64 out of this thing, and that's it. So, and for the D, we're going to have something like this, right? So it's going to be SV chop I64 SV, and yeah. Can I remove that? And I think I can also do something like this. Okay, so this is like way more readable than it was before. And now I can say saved, begin. And here I can just remove this entire thing. So if I run it, it does not compile. It does not compile on the line 50. So let's actually go to the line 50. So what does it say? Oh, because I have to actually do SV size, not just size. And everything is working as usual again. Okay, so I think it simplified everything, right? And maybe the time has come to sort of take these two definitions, the class SV and oh my god, the class SV and SV chop I64, and put it into some sort of like a common module that can be reused across several solutions. Because like reading and chopping things like that is way easier than like manually like this, right? So you don't have to keep track of the size anymore. So it kept track by these operations, so which is rather convenient. What do you guys think? Alrighty, so let me see how we can do that. So I think I'm gonna keep all of that in the common module, like high in hierarchy, somewhere here. So here are all the solutions, and here we can have something like maybe, I don't know, common HC, right? So let's put a little bit of documentation in here. Here we keep common code that is shared across all. Did I spell across correctly? I don't know. Across, maybe not. I forgot how do you spell across? Is that double C or it's actually single C? I don't know why. I actually like was not sure about that. Shared across all of the solutions. Right, and maybe I'm gonna split this entire line into two lines. Okay, so cool. Yeah, and I need to actually open two editors so I can copy paste a solution from one to another. So I'm gonna just do something like this. AOC 01 main HC, and let me quickly just like copy paste this entire stuff. So I'm gonna copy paste it in here, boom. So I'm gonna save it, and in here I probably need to also like include stuff. I wonder if it's gonna work, because the current folder is, yeah, probably it depends on your current folders. So probably you want to do it somewhere here. Right, because I already set it to this folder, common HC, and that should work hopefully. So I'm gonna save that and just quit that, and let me maybe make that a little bit bigger. So 01 HC. And if I try to compile this entire thing, okay, so I did file not found C common HC. All right, that is very interesting. So it literally tried to find that thing in there, which doesn't make sense. Okay, so we're gonna have some problems with, oh boy, with search paths. I'm not even sure how to do search paths, so maybe I'm gonna just do something like AOC 2021, and this is how I'm gonna include everything. Okay, so from now on, this is how I'm gonna include things until I figure out how to properly do include paths. All right, so this is basically everything what I wanted to do for this problem. So let me go ahead and commit the changes. Right, so the way we're going to commit the changes, I'm going to do sync to the host AOC 2021. Right, so I'm syncing to the host git diff. All right, so this is basically the changes that we made. So you see how much we actually compressed in here. So that's actually pretty good. This is how much we managed to compress. And so let me see, git status, git add AOC, git status, and then I can commit everything in here. Add common HC module. Okay, so I also want to remove main.c. Okay. IOC 2021. So, let's go to the second solution, right? In the second solution, we can probably try to use the same things. So O2, there we go, so main.hc. All right, so here we also have like a parse word, which is something that we probably also want to include in the in our common folder, right? So in case of a parse word, I'm actually looking for something that is, it's a little bit complicated, so I'm not really sure. We'll see. So first of all, I want to do the following thing. I want to include C home AOC 2021 common HC, right? Something like this, right? And parse word, or maybe in this case, I want to say something like chop word, right? So this one, as far as I know, you can't return structures in TempleOS, if I remember correctly. So we can even try to confirm that. So if I create something like foo, which is supposed to return structure, right, and then I create structure on the stack, and then I say that the size is going to be equal to 0, right, so this is 0, and the begin is going to be equal to null, right, and then I'm going to try to return SV. What's going to happen? I can compile everything, but if you take a look at the assembly of this function, there's something really fishy about that. I don't think it's going to work that well. Alright, so it basically allocates 10 bytes on the stack. I suppose that's the size of the structure. Then it assigns 0 to one field in here and 0 to another field. And then it adds first field to rex, which I assume is the way it returns the value. So, what? So I don't think it's gonna work, and furthermore, like, this entire code compiles, right? This entire code compiles. And if you try to sort of create SVA foo, this will not compile because you cannot initialize the variables like this. Right, you cannot initialize them like that. So it's kind of weird. You can create this function. This function will compile. It will do incorrect shit, and you won't be able to even call that function to return that structure anyway. So it is really weird, right? So you cannot do any harm, right, anyway, but it's just weird that this compiles, right? So yeah, the function that you're trying to write compiles, it is incorrect, but since you cannot use it, no harm is done. You see what I'm talking about? Do you understand the irony of this entire situation? Because it's really fucking ironic. Right, it's just like, okay. It's kind of weird. Why does it compile in the first place? No harm by design, yeah, I suppose. It's just kind of funny. Anyway, so this is just something that I wanted to point out. Alright, so, and because of that, we cannot return a structure, right? So because of that, if I want to return the string view, I have to return it through the arguments. So I want to do something like sv chop word, right? Word, and I'm going to accept sv basically input, right? So this is the input, and then we're going to have sv output, right? So this is going to be the word. Something like that, right? So, and this is where we're gonna start doing all of that stuff. So let me see. All right, so how are we gonna do all of that? So essentially, we have to kind of keep track. Yeah, we need like a variable I that starts at 0. And while I is less than input size, and So the input begin, is alpha or something like that. So it would be nice to have something like is alpha, right? So is alpha, but I don't think we have is alpha. Is there something like is alpha in TempleOS? Is there something like that? Because it's kind of weird that there is not. And I'm just a little bit afraid to create my own because maybe there is already something. Who knows? So let me see. HolyC is alpha. So I guess I'm gonna assume that there is no such thing as HolyC. So let me just create my own one then. So here I'm gonna assume boolean is alpha. So and here I'm gonna accept like u8, I suppose. So this is the character. So is there something like char? There is no such thing as char. Right, and in our case is alpha is essentially, so you know what, I'm gonna actually call it like x, right? So this is gonna be x, and we're gonna return a less or equal. And I think in HolyC you can even do things like that, right? So you can say this or a do something idiot. Thank you so much, do something idiot, for 3 months. Thank you, and welcome back to our TempleOS club. All right, so, and we can even do something like this. Not that it matters, but yeah. Is alpha. All right, so. And we're gonna put all of that into the common code, right? So all of that is gonna be put into the common code, right? While this thing has anything and this thing is alpha, we're gonna be basically incrementing I. But furthermore, I can probably say that it has to be like this, right? So it has to be like this. And after that, I need to do the following thing. Word begin is gonna start at the beginning of the input, right? So this is where it starts. Then word size is equal to I, right? That makes sense. Then input begin is essentially gonna be plus I, and input size is gonna be minus I. So that's essentially allows us to sort of chop a word out of string view, right? That's essentially what we're doing in here. So let me compile this entire thing. It seems to be compiling, and now we can remove this entire stuff, so it's not needed anymore. Okay, so we don't need size in here, so we have to do SV, and then I'm gonna do SV begin. And this one is going to be SV size. So here I probably need to keep the saved begin. Saved begin, SV begin. Alrighty. So, and I'm parsing a word. Which is rather interesting. So that means I need to have another SV, but for the word, right? Another SV, but for the word. Let me see. So this is going to be SV chop word. The input is going to be just SV. The output is going to be word. Right, like this. And oh, I do remember this thing. I do kind of remember, and I'm not even sure. So here we do additional +1, but it is needed just to trim some spaces, so we'll see how we can do that. Okay, so we parse a word, and in that case n, we don't even need n anymore, because now n is the size of the word, right? So this is going to be word size, and by the size of the word we can dispatch between these entire things and everything's fine. Alright, so then I can do SV chop I64. I do SV, and I'm gonna assign it, all of that to X. Right, but then I also need to remove that extra 1. So I need basically a function that will trim white spaces. Okay. So let me see. So I wanna make a small break real quick, just a second. Right, so let's continue. So what I need to do here is to go back to my text file. Let's go back to my text file, and it would be nice to just like have something like u0 sv skip, maybe not skip, maybe trim, right? Trim. Let's call it left, right? So it's gonna accept the SV and it's gonna be like basically trim left. But to be able to trim left, we need to be able to distinguish between the regular characters and the white space characters, right? So let's actually have something like boolean is space. And in our case, we're gonna have only 2 white spaces, I think, right? I wonder how I can do that. So we can try to assign the white spaces to basically the table of white spaces to some sort of like a string. So I'm going to do ws, and then here we're going to have a regular white space and the new line, right? So far. Later we're going to add more of them, so I'm not going to try to implement like everything at once. So do we have something like strlen, right? So we do have something like strlen, which is nice. Okay, I clicked on it and nothing happened, which is really weird. Let me do that one more time, please. Okay, thank you so much. And this thing, I suppose it just like it's string length, but it doesn't say anything about null terminated. Okay, so that's fine. Right, so this is gonna be something like this, and here we're gonna have I64. To be fair, maybe we don't even need to do that, because it is relatively easy to just do something like this while, you know, ws ws not equal, maybe not equal 0, or something even like that. I wonder what would be the easiest way to do that. So I have to actually compare it to 2 numbers. So while ws not equal 0, what we're doing in here is essentially if ws equal to x, we have to return straight up true, right? So we have to return true, something like this, and then I'll have to return false. Is there any way to simplify that? It feels like you can simplify that, but I don't want to be a smartass about that, so I'm not gonna just simplify that. I'm gonna just keep it like this. So, alright, and this is false, and we have an operation that distinguishes the white spaces. And I need to do the following thing. While I is less than sv size, and is space, this entire thing is a space, so sv begin, like this, we are essentially just incrementing I. There we go, plus. So, and I suppose after that, what I need to do is sv begin plus I and sv size minus I, right? So that is basically it. Cool, sv trim is space. So, and all of these things are going to become like a part of the common module. Again, maybe there is alpha or is space or something like that, but the auto-completion doesn't tell me if there is. Okay, so that's fine. So the first thing we want to do here before chopping the word, we want to kind of like sv trim left, sv first, and only then we want to chop a word, right? Only then we want to chop a word. That way, we should be able to quite easily just chop the I64 and get rid of this entire stuff. So that should be it, believe it or not. And here we have to just do saved begin. So, and I think we're done with the part 1, so it definitely simplified the part 1 a little bit. So if I try to compile this entire thing, it does not compile. Let's actually go to the compilation errors, 46. So what do we have in here? So size does not exist. We have to look at the SV size, right? So here's the SV size. And another problem, 75. Let's go to the 75. And I'm not quite sure what it's talking about, so there's nothing in 75. Saved begin in part using 64 register variable. I don't quite understand. So is that because I think I know what's going on here. I forgot to make this a pointer. Right, I forgot to make this a pointer. Okay, so there's the next problem. 85. So and in here, oh, again, we just don't have, you know, parse word anymore. So let me actually comment it out for now. So I'm commenting everything out in here, and also gonna comment out part 2. So the thing I want to do in here, oh, okay, so it actually hang. That's kind of sad. So wait a second. Yeah, it hangs. Unfortunately. So I made some mistake somewhere. I make a severe mistake somewhere, and I'm not really sure where. So that is really sus. And now we need to understand where exactly we did it. All right, so where exactly we did it. It feels like maybe if I try to print the size, right, so let's actually go ahead and print the size and see. So it's probably some of them are not trimming everything correctly or something like that. So yeah, it's probably something like that. So this is going to be new SV size, and if I try to do that, it didn't even print anything like at all, which is really strange. So that means it hang somewhere inside of like a trimming process, or maybe somewhere inside of the... Oh yeah, okay, of course, inside of the space, because I never incremented the space. I see. So that makes a lot of sense. Thank you very much. And now it is actually working. Okay, so that was actually relatively easy to catch. I'm super happy that it was relatively easy to catch. Okay, so it's 203. I want to actually like confirm that that's the problem that we have in here. So this is the second one. I mean, that's the answer, 203. Okay, so that's fine. Cool. So next I want to port the part 2, right? So I'm going to quickly port the part 2. So I'm going to do it like that. All right, so and then I'm going to basically remove this entire thing. Okay, so let's actually start porting this thing. So in here we don't need that, but we do need to allocate two string views, SV and probably the word, because we're also going to chop in the word. So in here we're going to have SV begin, and then here we're going to have SV size. So this stuff is not needed anymore at all, which is nice, but we do need saved begin super quick. So saved begin, and it's going to be at SV begin. Okay, cool. And then we're gonna have SV size, and here is pretty much the same process, right? It's pretty much the same process. We do SV trim trim left, we trim in the left part, and then we do SV chop word. We provide SV and then the word, and then we have to chop the value, right? Chop X. SV chop I64. So it's gonna be SV. And it's going to just return X, which we're going to assign in here, right? So this is going to be something like this, and this is going to be something like this. And in here, instead of N, I'm going to be using SV size. There we go. So I suppose here I can also going to do SV size. So that means we don't really need N anymore, and I can remove it quite easily. And I wonder if I need to remove it from the part 1. Yeah, so it never complained about unused variable n, but maybe it is used because... I suppose it is used in the okay, so that makes sense. Yeah, so that's why it never complains about that, because it's used in unreachable, which is... yeah, which is not that important, but it is what it is, and it isn't what it isn't. So here we have a saved begin. Right, and here I'm going to save everything, and if I run it, everything seems to be okay. So we actually got unreachable. apparently. We actually got unreachable because I'm actually using SV instead of Word. I have to use Word in here. And now everything's fine. And I roughly remember that this is the correct answer. So it's, yeah, it's roughly that. Okay, so that's cool. So we finally ported the second solution, right? So we extracted some things that could be useful in other solutions, like is alpha, is space, trimming left, and so on and so forth. So, and let me quickly pull it out into the comments. I wonder if I can just go into this file. I probably cannot, but whatever. Okay, so let me see. How can I bring everything up in there? So probably can just bring the terminal here, right? AOC, I'm gonna open the common stuff, and I'm gonna go in here, right? So I'm gonna go in here and just do this thing. Alrighty. So this is how much code we managed to extract into the common parts, right? So boom, right? So I'm gonna save that, and I'm gonna just exit this entire thing, and I'm gonna try to compile this one more time. So there is something weird in here. Why do I... Oh, okay. I forgot to copy paste like a single thing in there. Hopefully maybe the compiler will complain about that so I can jump for... Really? What are you talking about, mates? Did I forget to save? Right, what does it want from me? It says that I'm missing semicolon at the line 4. Ah, this is because it included it in common and it actually never... Alright, I see what's going on. This is really, really weird, but it is what it is. Okay, I'm gonna do common, and yeah, because of the error in here, it complained about the error in a different file. What a nice compiler. Thank you so much, Terry. Very cool. Alright, so, and in here I'm gonna open this main, and it still complains about something in here. What do you want from me? Didn't I not save common HC? Apparently I did not. I thought I saved it. Okay, I press Ctrl S, and now it should be fine. And if I open this thing and do F5, everything is finally fine. Okay, so we extracted a little bit more code into the common parts. Right, so, and let me quickly just go and commit them. Oh boy. Alright, so sync into the host. Right, so I probably have to provide the AOC image, right? Okay. So, and here are the changes that we have. So, yeah, so this is what we extracted, and then somewhere down below we're gonna have something that we already added. Cool. AOC commit, move some code from day 2 to common, right? So I'm going to commit that, I'm going to push that right into the repo, right? And if you want to get the source code of the repo, you can find it in here, right? If you're watching on YouTube, if you're watching live, I'm going to copy paste this thing in the chat, right? I'm going to post it in the chat. Alrighty. So let's go. So we need to now adapt this code for the third problem. So let's just do this thing. It's gonna be run AOC 2021. There we go. Okay, go. 22203. So this is the third one, and I suppose here we're not gonna have anything particularly special in terms of parsing, right? Because we're only parsing the numbers, so this should be pretty straightforward. Hopefully, we'll see. So here I need to include C home AOC 2021 common HC, and that's it. So if I try to compile this entire thing, it compiles quite easily. Okay, so I'm gonna remove the size. Here we'll have to probably allocate just SV, a single SV. Right, so this is gonna be SV begin, and then this one is gonna be SV size. So in here, we don't need any of this stuff. U8, saved begin, SV begin. All right. So here we only operate on size, and I'm gonna just do this stuff. And it's going to be SV, maybe something like SV chop I64. So I have to provide SV, but this time we're parsing the binary numbers, right? So that means the radix has to be 2, right? This time I'm providing radix, which is nice. All right, so I'm going to save this entire thing. And in here I have to do saved begin, right? So this is going to be the saved begin. And I'm going to run it and everything seems to be running. Okay, so that was actually pretty easy. We already have a lot of code, so it's pretty easy to adapt. I mean, a lot of code in the common, right? We can just reuse that code. We don't have to write it from scratch. SV begin. And then I'm going to do something like SV begin, and then SV size. And here I'm going to just do that. U8, saved begin, SV begin. Alrighty. So, and so what do we have in here? So that should be just this. SV chop I64 SV2. Do we need anything else in here? I think that is it. That is everything. And if I try to compile this entire thing, and of course it doesn't compile because at 65 I forgot to put SV in here, of course. So, and at 76 there was something else as well. So what exactly was it? Invalid L value, SV chop I64. So why would it be invalid L value? I'm not quite sure. Is that because, okay. Wait, what? Okay, let's read it one more time. Free. Oh, okay, so it's not here. It's actually free. But why is it complaining at 75? Like 75 and okay, all right. So I probably jumped in the correct place. So it has to be saved begin. All right, that makes sense. Cool. Alright, so we extracted some code, we basically reused some code in the third problem, and I think this is all of the refactoring I wanted to do. I wish the text editor was a little bit better because it's really painful to like move code around and stuff like that. But yeah, I managed to like extract some code that could be useful in, you know, further development. And as we develop more and more like patterns, we're gonna just move those patterns into the common thingy and reuse them. So that's basically the idea. Alright, so let's actually go and commit everything we've done. So let me do something like sync host AOC 2021. So I did that. All right, so here are the changes. And this is going to be status add AOC git commit use common code in day 03. Right, I'm going to push that right into the repo origin master. All right, so I think we're good to go and actually ready to do the fourth day, hopefully. So let me see. Okay. I don't know, maybe I'm gonna actually split this into two videos. Like this is gonna be a video dedicated to developing this string view library, and the next video is gonna be the fourth day, so not to mash everything together. I think I'm gonna do that. So yeah, see you in the next video, I suppose.